The first part of understanding limits of functions in real analysis is on the understanding of cluster point or cluster points on a specific set. So we need to define them first, and later on in a separate video, we're going to come up with illustrations of examples in determining the cluster points. For this, let us give the proper definition of a cluster point. Let A be a subset of set of real numbers. A point C, any point C which is a real number is a cluster point, okay, of A if for every delta greater than 0 there exists at least one point, okay, one point x which is an element of A, but x is not equal to C, such that the absolute value of a difference of x and C is less than delta. This means that the point C is a cluster point of set A if every neighborhood of delta, or every delta neighborhood of C contains at least one point of A. Say for example, if we have this real number line, and say for example this is our subset, of course this is a real number line, this is our set A. Okay. If there exists point C here, which is an element of real numbers, or even C can also be non-element of A as long as it's an element of real numbers. And if we could locate for any delta, however small is that, okay, so this is minus delta, this is plus delta. If we could locate one point in this, say for example this one here, x, that is not equal to C, then we can consider C to be the cluster point of A. Okay? So this means that we need to identify first the set, and then later on identify what are the cluster points. So in a separate video, the next video, we're going to determine cluster points, or if an element or a real number is a cluster point of the given set. Thank you very much for watching.